Okay, so today I am gonna discuss another problem from TIFR PYQ. It's from 2022, and the problem statement is very simple that you have to calculate the power radiated by a point charge Q moving rapidly with a uniform speed V in a circle of radius R. So the situation is kind of this: you have a circle of radius R, and a point charge is moving, point charge Q, and the instantaneous velocity is V. So very less information and straightforward problem, but if you don't know this, how to solve this and the direct formula, then it will be extremely complicated. Okay, sorry, maybe I paste it in the last page. Okay, but doesn't matter. Okay, so first let me tell you the formula for this, and then I will tell you that how to get that formula, how to memorize this formula. Okay, so the formula for this is mu naught q square by 6 pi c gamma to the power 6 a square minus v v cross a. V is the velocity, a is the acceleration, and gamma is the special relativity gamma. Okay, so what is gamma? Gamma is simply 1 by root under 1 minus v square by c square. Okay, so don't tell me that derive it in here, because radiation is itself a very complicated thing, and if you want to know that how these derivations and all this coming, you should have go through Griffiths, because Griffiths has I followed Griffiths, and Griffiths has done extremely well for this chapter. Griffiths chapter 11. Chapter 11 is basically power radiation by dipole, but the next section of this chapter also describes the power radiated by point charge. Maybe section 11.2, I guess, and here these things are very beautifully done. All the derivations and some examples also. Okay, so you can follow that, but I will suggest that if you don't do radiation till now, then for exam purpose, for your TIFR exam or maybe NEET in January, February, don't go through. But I mean, I will suggest that don't try to do all this derivation, because it's extremely complicated itself. Try to just remember the key formulas. Okay, then you will be done in exam hall if this type of problems come. Okay, so now I will tell you little bit that how to memorize this formula. Okay, even I also don't memorize all the things from that, but I by some trick I can memorize. Okay, so the basic thing you have to keep in mind, the first thing, that the basic Larmor formula. Okay, so you know the Larmor formula, because Larmor formula comes many times in your course, also in QM course. Okay, the time dependent perturbation course, you also know the Larmor formula. So the average power dissipated is mu naught q squared a squared by 6 pi c. This is your Larmor formula. Okay, this thing you have to keep in mind. Otherwise, you can't memorize this complicated formula. The first thing is this, but let me tell you few things. This Larmor formula has some things, approximations. The first approximation is V is much less than C, so non-relativistic case. Okay, so if you don't assume this condition, then your Larmor formula will get modified according to this: u naught k square s square by 6 pi c, but there will be a gamma to the power 6 here. Now, how gamma to the power 6 is coming? This problem is done in Griffiths. Okay, there is an example in Griffiths in section 11.2, and this example is not very complicated example and beautifully done in Griffiths. Okay, so you can see that example. So this is the first thing that you have to do. First, write, remember the Larmor formula. Then think that what should be the factor you should put here when V is not much less than C. This condition is not there. So this is the modified Larmor formula. But till this formula is valid when your charge is moving in the direction, let's say acceleration A, and you don't have any other kind of velocity, like you don't have a fixed velocity in other direction. So this is the direction of A, and if you have a constant velocity V in some other direction, then this formula will not be valid. This formula is only valid your A is same direction and your V is also in same direction. Okay, this is the thing when this formula is valid. But to account this kind of configuration, when there is a constant velocity v and a constant acceleration a, but their direction is not same, then your formula will get modified further. So the previous thing was mu naught q square a square gamma to the power 6 by 6 pi c. This was the formula. Now your v and a are not in same direction. Okay, so your v and a are not in same direction. There is some angle, let's say theta. So how your formula gets modified? Now the final thing. So let so now your final thing, your a square should always be here. So just put a square. But to keep this thing in account that v and a might not be in same direction, just put a v cross a, and to make it dimensionally correct, divided by a c. So look, here the dimension is acceleration. Here is still the dimension acceleration square, and here still it is acceleration square. But you have to put a v cross a by c to make it dimensionally correct. So this will be your modified final formula, and this will be valid for every configuration, the most general configuration. Okay. Now you can easily get a check that if your v and a are in same direction, then this term go to 0 and this term only survive, so you will get your previous thing, the this kind of configuration. So yeah, it's get satisfied. Okay, so this is the way where you can remember, this kind of way you can remember. First write the basic Larmor formula. This is the basic Larmor formula. Then write the relativistic Larmor formula, account a factor of gamma to the power 6 here, and then you can think that they can v and a cannot be in the same direction. Then think in this way to dimensional matching v by c, and there is a cross product of v cross a. Okay, so this will be the way you can remember. Now back to our original problem. So there is p is equal to mu naught q squared gamma to the power 6 by 6 pi c, and v is perpendicular to a, right? So in a circle, your acceleration will be a centrifugal acceleration. Then it is acceleration is v square by r, but let us put it later. But here is v, here is a, so they are in perpendicular direction. So v cross a is equal to simply va. So I am putting this a square outside, and it is simply 1 minus v square by c square. Okay. Now what is 1 minus v square by c square? It is simply 1 by gamma square, right? Because gamma square is 1 by root under 1 minus v square by c square. So your formula gets modified, a square gamma to the power 4 into 6 pi c. So this should be your final answer, but remember your final answer will given in terms of epsilon naught, and you also didn't put till that a is equal to v square by c. So you have to put these things as well. So let me write again, mu naught q square a square gamma to the power 4 a square gamma to the power 4 by 6 pi c, by 6 pi c. Okay, so multiply a epsilon naught in both numerator and denominator. Now what is this mu naught epsilon naught? Mu naught epsilon naught is simply 1 by c square. Okay, so 1 by 6 pi epsilon naught c cube. Your q square is there, a square is v square by r, so v to the power 4 by r square, this will be your a square. And what is your gamma square? Gamma square is simply gamma to the power 4 p square by c square whole square. Okay, so now let us calculate q square 6 pi epsilon naught r square v to the power 4 by c cube into c to the power 4 divided by c square minus v square and whole square. Do a little bit simplification, and you can write it v to the power 4 as v squared whole square. So your q square c cube c4 get, you will get c 6 pi epsilon naught r square into v square by c square minus v square whole square. Okay, so this will be your final answer. So you can see that if you know the direct formula, this direct formula, then you will be done in just 2 minutes. Okay, but if you don't know this formula, then you cannot get this simple problem. Okay, I mean, I will not say it's simple, but if you remember the formula, then it is simple. Otherwise it is extremely complicated. So yeah, this kind of problem, for this kind of problem you should have remembered this formula for at least now, from now on 2 3 months, because all the competitive exams are in 2 3 4 months. So from now on, till 3 4 months, you should have remembered this formula, because if this kind of problem comes, then this formula is the most general formula. You can do any kind of problem from this formula. Okay, so that's it for today, and next we will meet some other PYQ of this 2022. Thank you.